Hello everyone, well we've made it to chapter 3, so now it's time to start talking about the mechanical properties of materials. Mechanical properties of materials, and mostly how our stress and our strain are connected together. What connects them? So you're going to understand that, and you're also going to understand what this modulus elasticity E is. Okay, so this time we're going to focus on the applications and tension test, and then we'll go on from there. So first off, now we've shown in previous chapters that when an object is placed under load, it will deform. However, how do we determine when a load is too great for a material? As you can see right here, that was okay, that was not. And even in this case, there's a necking here. That means that it has permanently and irreversibly changed its shape. That's not good. Now we can see that both bars experienced great deformation. That's coming from the necking right here, we can tell that. But why did the second one fail? If you zoom in here, you can kind of see that it fails in a cone shape. So what does that mean? Is there a reason for that? Well, we're going to find out. Second thing is, all of these structures in New York are made of massive amounts of materials. How do we know that the materials they're made of will be able to take the loads that they are under? You can't find out afterwards. You can't build the Empire State Building just hoping that the beams at the bottom and the bricks at the bottom will be enough to hold the top. You can't guess at this. You have to know. So how do we figure this out? Well, we do it through something called a tension test. So, as an engineer, before you can use any material, you have to understand its mechanical behavior. Now, we typically do this with a tension test because all bodies will deform under load, and it's going to result in permanent deformation and then failure. If you don't know when that point happens, either the permanent deformation or failure, you're obviously going to be setting yourself up for a bad time. We have to understand the limits of what we work with if we're going to work safely. So the behavior for materials is typically investigated through a tension test. What we have here is we have two sides. They apply a particular load to the material. And then right here we have some knife edges which are at certain points in my material. And this guy measures how far it has deformed as we continue to increase the load. Further and further and further and further. Now our sample has a known cross-section, and it has a known original length. Not delta, sorry, that's just del. And so from that we can calculate a lot. Now eventually, as the object is approaching failure, the specimen will exhibit something called necking. That's right there. Now, I think you can figure out what I'm referring to by this. It forms literally a neck. It goes from being a cylindrical tube to one that has a kind of a waist. And that's because at some point, all of my deformation is focused in a particular point. Before this point, it gets longer and thinner all at once. So you have a fat cylinder that becomes a long but thin cylinder. At some point, it can't do that anymore, and bonds begin to break to continue to allow it to be stretched. Eventually, those bonds completely break. We're going to find out probably later why this cone cup structure happens, but I'll go ahead and tell you, it's all based on how elastic the material is. The more visible the necking, the more elastic the material. The less flexible the material, the less necking you'll see. Until finally, if you have something like glass, you will not see necking, it just shatters without ever showing any visible necking. Okay, so that's where we're going to stop this time. Just introducing the fact that there is something called a tension test, and we do this to figure out the mechanical properties of materials, to figure out how much stress it can take and how much it will strain underneath that stress. So next time we're going to show the results of this tension test, what it looks like, and how we interpret it. So thanks for listening. I'll see you all next time. Bye-bye.